today's chemistry session. Today we will study in this session the topic nomenclature of coordination compounds. When we see a person first, we will notice his or her physical appearance. Then the next thing we want to know about that particular person is his or her name. I told you earlier itself that chemistry is closely related with the life of a human being. Same as that. So, if we want to know better about coordination compounds, the next step is to know its name. How to write the name of the coordination compound. In chemistry, we can write the name of the substances in two different ways. In one way, in the normal sense we can write it, which everyone can read. In the other way, we will write the name of a particular substance by using chemical symbols that only a chemist can read. And that name is known as the formula of that particular compound. So first, in this session, we will study about how to write the formula of a coordination compound.
Nomenclature is very important in coordination chemistry when we deal with coordination complexes. This is very important in order to write systematic names with clear meanings. In this topic, we will follow the recommendations of the International Union of Pure and Applied Chemistry, that is IUPAC names of coordination compounds. To provide basic information about the constitution of the compound in a short, suitable and easy manner, we use a shorthand tool in chemistry that is known as formula of a compound. You know about it. Let's see the rules that are applied when writing the formulas of the mononuclear coordination entities. What is meant by mononuclear coordination entities? Those coordination entities which contain a single central metal atom or ion is known as mononuclear coordination entities. First rule is central metal atom is listed first. If you want to list the central metal atom first, you should identify the central metal atom in the given name of the coordination compound. So, it will be probably a D block element. So, that metal that is present in that coordination compound in the given name, you should be able to identify, and it should be listed first in the coordination entity. You can see here an example, nickel tetracarbonyl. So, inside the square bracket, that is in the coordination entity, what is written first is the name of the central metal atom, that is nickel. So, in this way, you should sort out the name of the central metal atom first from the given name of the coordination compound, and its formula, that is formula of that central metal atom, should be listed first inside the coordination sphere or coordination entity. Second rule, ligands are listed in the alphabetical order. Here we have a coordination compound as an example. The name of this coordination compound is diamine dichloridoplatinum 2. So we have two ligands here. You can identify two ligands in the given coordination compound. One is NH3 and the name of the ligand is amine. The other one is Cl and the name of the ligand is chlorido. So A comes first, then C. That is in the alphabetical order. The ligands are arranged next to the central metal atom or ion. That is the second rule. In order to arrange ligands in the alphabetical order, we should know the name of the ligand. Here I have given names of some common ligands. Bromide, Br minus, is bromido. Carbonate, CO3 2 minus, carbonato. Chloride, Cl minus, chlorido. Cyanide, Cn minus, cyano. Fluoride, F minus, fluorido. Hydroxide, OH minus, hydroxo. Oxalate, C2O4 2 minus, oxalato. Oxide, O2 minus, oxo. So those names of ligands which are carrying negative charge will be ending up with O sound. Bromido, carbonato, chlorido, cyano, fluorido, hydroxo, oxalato, oxo, etc. Let's see the names of some neutral ligands also, which we may use often. Here we have ammonia, and the ligand name is amine. Water, aqua. Carbon monoxide, carbonyl. Ethylene diamine, and its abbreviation is EN. In many cases we use this abbreviation EN instead of saying ethylene diamine or ethane 1,2-diamine. These three names, like ethylene diamine also you can use, ethane 1,2-diamine also we can use, and preferably we use EN, the abbreviation of ethylene diamine. Then methylamine is ligand name also the same, methylamine. Third rule, polydentate ligands are also listed alphabetically. Use the first letter of abbreviation in case of abbreviated ligand to determine the position in the alphabetic order. Here you have an example, COCl2 En twice plus, that is the coordination compound. And you have a didentate ligand there, that is ethylene diamine. As you have heard, its abbreviation is used here. Abbreviation of ethylene diamine, En. You can see what is written in the parenthesis. So, when abbreviation is used, if you want to take into consideration or if you want to arrange the ligands in the alphabetical order, you have to see the first letter of abbreviation only. No need to consider about the name of the ligand. But when a ligand is written in abbreviation, the first letter of the abbreviation is used to consider or to arrange it in the alphabetical order. So here chlorido comes first and then En. So written in the alphabetical order. Fourth rule, use square brackets to enclose the formula for the entire coordination entity, whether neutral or charged. That you have already learned about when you learned about coordination sphere or coordination entity. What is inside the square bracket, including square bracket, that is known as coordination sphere or coordination entity. So when you write the coordination compound, the coordination entity should be marked with a square bracket. That is, it is the square bracket that tells you that it is the coordination entity that is inside the square bracket. So it is compulsory to write it with the square bracket. Then use parenthesis to enclose polyatomic ligands or abbreviated ligands. Here in this example you have COCl2 En twice Cl. So this En, ethylene diamine, is an abbreviation. So abbreviated ligands or polyatomic ligands should be written in parenthesis. So you will not get any doubt or confusion when you name it. That is it. Fifth rule, within a coordination sphere, there should be no space between the metal and the ligands. Here I have given example which you will be understanding very clearly. See CrCH2O 3+. It is written in an order just after the metal ion or atom. Ligand is written. If there is one more ligand, that ligand is also written very closely without having any space in between. So in the second expression you can see, after Cr, the central metal atom, there is a space. Knowingly or unknowingly, if you write it with a space, that particular formula which you have written is going to be wrong. And as you know, the writing the formulas of coordination compound is a very important topic when in the point of view of exam. Rule number 7, to write the formula of a charged coordination entity without that of the counter ion, indicate the charge outside the square brackets as a right superscript with a number before the sign. Here you have an example, COH2O 6 times 3+. So that 3+, first the number, then the charge, is written as a right superscript outside the coordination sphere. So this compound, coordination compound is charged. If you write Cl3 instead of 3+, there outside the coordination sphere, if you write Cl3, that is, Cl is having a negative charge. If you write 3Cl, that 3 plus charge will be getting cancelled and you will get a neutral coordination compound. So in that case, that is the role of a counter ion. If there is no counter ions present, that charge that is existing on the coordination compound should be shown as a right superscript outside the coordination sphere. Sixth rule, balance the charge of the cation by the charge of the anion. Here in the coordination sphere we have Zn, which is having 2 plus charge, and OH, hydroxyligands. OH is having 1 minus charge. So 4 OH is there. So we have 4 minus. 4 minus is there inside the coordination sphere and 2 plus is there. So still 2 minus is remaining. That negative charge is neutralized, balanced by using the counter ion, which is having 2 positive charges, K2. So 2 positive charges. So in this way, we have to balance the charge of the cation by the charge of the anion. When we practice a few examples, you will learn to write the formula of a given coordination compound very easily. So you will see the first example. The name of a coordination compound is given, diamine dichlorido platinum 2. So when we think about the rule, what is the first rule? Central metal atom should be listed first. So which is the central metal atom is there? Only one metal is shown here, that is platinum. So platinum in its plus 2 oxidation state. In the bracket, in Roman numerals it is written 2. So platinum is the central metal atom in plus 2 oxidation state. So that you have identified. So that should be listed first. Then look into the ligands. 2 ligands are given there. Diamine. Diamine means 2 NH3 ligands. Dichlorido. Dichlorido means 2 Cl minus ligands. So we can see the alphabetical order. So amine comes first. Di or tri, that is not our consideration. We'll see the first letter of the name of the ligand. So amine comes first before chlorido. So we will write PT NH3 twice Cl2, and that we will be putting in square bracket. So we have successfully written the formula of the given compound diamine dichlorido platinum 2, that is PTNH3 twice Cl2, and it is written in a square bracket to mark it as a coordination compound or coordination sphere. Let's see another example. Write formula for the following coordination compound. Potassium hexacyanoferrate 3. Here you can see 2 metal atoms or ion, that is potassium and ferrate. Ferrate is iron. But you should be able to clearly identify that potassium is not the central metal atom or ion. One thing, it is not a D block element. Next thing, after potassium there left a space. After central metal ion there should not be any space between the ligands and central metal atom. So that is one thing. Then why potassium is used? Potassium is used as a counter ion. So after writing the name of the counter ion, there will be a little space between the central metal atom and ligands. That will be written separately as a coordination entity. So here we have ferrate. Why iron is written as ferrate? When the particular coordination compound is negatively charged, we use the term ATE, 8. So it is written as ferrate. So that 3 charge is negative charge. That 3 charge that is shown for central metal atom here is negative charge. That is why it is written as ferrate. So hexacyanoferrate, we have hexacyano, 6 cyanide ligands, 6 Cn minus ligands and iron in plus 3 oxidation state. So the total charge on this coordination compound becomes 3 minus. That is why it is written as ferrate, hexacyanoferrate. And this 3 negative charge will be cancelled by the presence of counter ion potassium. So potassium is having only 1 plus charge. So how many potassium you have to take? 3 potassium. So the formula will be K3FeCN 6 times. FeCN 6 times will be kept in square bracket to show that it is the coordination entity. Let's discuss yet another example to make writing formula more easy for you. Write formula for the following coordination compound: tetraaqua dichlorido chromium 3 chloride. So you can sort out first which should be listed. Central metal atom or ion should be listed first. Here we have only one d block element, that is chromium. So that is the central metal atom. So chromium is listed first, and then we have how many ligands? We have 2 ligands here. One is H2O and the other one is Cl minus. Tetraaqua 4 H2O ligands and dichlorido 2 Cl minus ligands. And you see, after the charge of the coordination compound of central metal atom, chloride is written after that. So chloride is a counter ion. If we have a negatively charged coordination entity, we write the counter ion first before the coordination entity. If we have a positively charged coordination entity, here this chromium 3 is 3 plus charge. So that coordination entity will be written first, and then will be written the counter ion. So we'll see how the formula is written. CrH2O 4 times Cl2, then square bracket. After that the counter ion is written Cl. Here in the given formula we have Cr with 3 plus charge. It's shown in the given name. And then H2O is a neutral ligand. Even though it is 4 in number, it has no charge to contribute. It is neutral. Then Cl2. Cl is having minus charge. 2 Cl means 2 minus. So 3 plus 2 minus. 1 plus charge is remaining. That 1 plus charge is cancelled by the counter ion Cl. So only 1 Cl is needed. So this is the formula of the given coordination compound.
We have learned about how to write the formula of a coordination compound. I hope you have understood in detail. So this is the end of our session today. Thank you. See you again.